All right, so we are going to continue on with Unit 10, talking about today specifically isosceles and equilateral triangles and kind of seeing some more of those relationships we talked about in the previous lesson. So isosceles triangles, remember, are triangles with at least two sides congruent, and then legs are the congruent sides. Okay, so like here's an isosceles triangle. This and this would be our legs. And remember, and if they are isosceles, remember we show that they're isosceles by those little tick marks. Okay, and then we have our legs, and then this is called your vertex angle. So right there is your vertex angle. Then we have our base. So this entire side is your base, whereas your base angles are here and here. So this and this, these are your base angles. Okay? So that's just some vocabulary. And then notice your base is always opposite your vertex angle. So then now we have the base angle theorem. The base angle theorem is if two sides of a triangle are congruent, then the base angles are congruent. So if the sides are congruent, then we know that the base angles are congruent. Okay, so sides going to angles. So if we know that this side is congruent to this side, then we know the angles are congruent. So those are the statements we're going to show. So it says mark which parts are also congruent based on the picture, and then write the congruent statement. So because we know the sides are congruent, we know that the angles are congruent. So we would say if side BC is congruent to BA, okay, BC is right here, BA, then we know the base angle, which is C, angle C is congruent to the base angle A. Okay, so if BC is congruent to BA, then angle C is congruent to angle A. Okay, same thing here. If we know side, and I'm always going to probably start with the vertex, so the vertex angle. So I would say CB is congruent to CA. So start with the vertex angle on both of them. So CB, CA, rather than like going CB and AC. If we know CB is congruent to CA, then we know angle B is congruent to angle A. And that kind of goes with this, right? C and then B is your base angle, C and then A is your base angle, angle C is your vertex. Okay, so the same thing here. Again, we label it, right? We show those little arcs. So then again, start with your vertex. AC is congruent to AB. Therefore, we know that angle C is congruent to angle B. Okay, and we can even find their measures, right? If this is 45 degrees, this is 45 degrees. If this is 57, this is 57. This is 79, this is 79. That's what it means that they're congruent. Okay? Then we have the converse, so that goes the other way. If the angles are the same, then we know the the sides are the same. So if the base angles are the same, then we know the sides are going to be the same. Okay, so that's called the converse. It's going the other direction. So we would say if angle A is congruent to angle B, then we know here our two sides are congruent. We labeled it. And then we would say side CA is congruent to side CB. And again, start with that vertex angle and then go down. Okay, again, angles are congruent, so angle C is congruent to angle B. So therefore, labeling our picture and then writing it out, notice I almost put AB. AB is not the same as C, so we have to go AC is congruent to AB. So the base angle has to go with that side. So B would have to go, angle B would have to go with side AB. Angle C has to go with side AC. Okay? All right, so then now we're going to keep going with this, kind of getting more and more into these examples and talking about like more complex pictures, right? So if segment AE is congruent to segment DE, then what? So let's label it. Here is AE, and here is DE. Okay, then what angles do we know are congruent? These are the base angles. You would say angle A is congruent to angle D. So angle A congruent to angle D. Those are our base angles for those two sides. Then notice now we're going angle. So this would be the converse, right? Because we're going angle two sides. So angle EDC, EDC is right here, is congruent to CED. So that's this one. Okay, so those are congruent. Then we know the sides, CE is congruent to CD. But I should write that out the other way around, right? I should write it this way. So if I start with angle EDC, I should really start with side CD. Okay, and then this goes, CED, so I should really say then side CE. So I should write it this way. Okay, and the next one, if we know AB is congruent to EB, then the angles, we have angle A. That one's kind of the easy one. Angle A is going to be congruent to this angle, but we can't call this angle C, remember, or angle E. The reason we can't call it angle E is because angle E could refer to all three of these angles plus the really big angle. So we have to be more specific. So this we'd have to call it angle AEB. Okay. And then if angle EBC is congruent to ECB, then we would know that these two are congruent. And again, let's start with this side first because that was the first angle. So we'd say EB is congruent to EC. Okay, angle to segment to sides. So angle to sides, sides to angle. Okay. Now we have the equilateral triangle theorem. So if two triangles are equilateral, then they also are equal angular. So if we know all the sides are congruent, then we know all the angles are congruent. That's kind of what I was kind of referring to yesterday or on the previous lesson, but this specifically says it. And then now this goes the other way, right? So we have the theorem first, now we have the converse. The converse goes the other way. It says if the angles are congruent, then the sides are congruent. It says now we have the angles of an equilateral triangle. Each angle of an equilateral triangle is 60 degrees. Because think about it, if they're all congruent, and I have to do 180 divided by 3 angles, the only way to get that is 60. So all of them are 60 degrees. So this is 60 degrees. This is 60 degrees. This is 60 degrees. Okay, and again, that also means that all the sides are congruent. But we don't know what the sides equal. That's harder we can't really find that out without more information. But the angles we always know. Okay, so now we have some more examples here. If we know that all angles are congruent, we know all the sides are congruent. So if this is 8, that means x would have to be 8. Right, so we're solving for x here. This would, I could even write out equilateral, or really I could say equiangular. Therefore equilateral. This, we know that it's isosceles, right? Or I could even say, I don't even have to say all those, right? I don't even have to use the words if I don't want to. I could just say, we know that angles congruent leads to sides congruent, right? And specifically all three. This one is an isosceles where two sides are congruent, so you'd say congruent sides means congruent angles, base angles. Okay, but notice we're talking about the base angle here. We don't know what this would be. That would be harder to find out. We'd have to do a little more work, which we will eventually, but this one is easy as just saying 65 degrees. Okay, so like this one, we know this is 65 degrees, therefore this is 65 degrees, but not this one. This one we have to figure out. And remember, all three angles add to 180, so you would do 180 minus 65 minus 65 to finally figure out what x is. And x in this case is 50 degrees, right? 180 minus 65 minus another 65 is 50 degrees. Okay, so that one was hard to figure out. We had to say that, okay, then we know our two, because the two sides are congruent, we know the two angles are congruent, and we work backwards to finally find that third angle. Okay, if we know the two base angles are congruent, we know the two sides are congruent, so we know this is 7. Two base angles are congruent, therefore we know the two sides are congruent, so this has to be 9. Okay, find the base angle that goes with this. Here's one base angle, here's the other. We don't know what x is yet, so we know this is 47. We have to do the 180 minus 47 minus 47 to finally figure out what x is. And in that case, it is 86 degrees. Okay, 2 more examples here. So now we have, this one gets a little more complicated here. It says we have 38 degrees, but if our two sides are congruent, the two base angles, not the vertex, the two base angles are congruent. So we know these are the same. So we kind of have to set up an equation here. So we would do, we have two x's, right? These are both x. We don't know what it is, so you'd say x plus 38 equals 180, okay? Because that one's harder to figure out. Okay, so x plus x is 2x plus 38 equals 180. Subtract 38 from both sides. 2x equals 142. Divide by 2. X equals 71. Okay, what that means is that this is 71 degrees. This x here is 71 degrees, and this x is 71 degrees. And you can double check it. Okay, 71 degrees plus 71 degrees plus 38 degrees is 180 degrees. Okay, that's how we know you kind of are doing it correct. You might only have 1 or 2 on your whole entire homework assignment this complicated. The rest of them are going to be pretty easy. So here are your two base angles are congruent. Therefore, our two sides are congruent. So if this is 11, this is 11. All right, now you can work on the assignment.